What is chemistry? Chemistry seems to be full of long complicated names such as endothermic or 2-amino, 3-hydroxyl, 5-oxy-7-phenyl-heptane. However, we have to start at the very basics before we start going to the more complicated stuff and the big explosions seen on television. Today, we're going to explore what chemistry is and some crucial terminology. Chemistry refers to the study of matter and its composition. It answers questions such as, what happens when two substances interact? And as you explore these different facets of chemistry, you will start to unlock some of the mysteries of the universe and perhaps find the answer to life, the universe, and everything.
Although key terms are boring and seem like useless knowledge, they can help us avoid calling things things. Now, whether you like or not, you're gonna have to be clear when you're talking about chemistry, or anything for that matter.
Matter. Does someone say something about matter? Well, it's everywhere, and anything that has mass and volume is matter, like a tiny electron, which is very small, but is still considered matter. Some things, however, are not considered matter, such as the photon, which is a particle of light, or heat.
Matter can be characterized in two different ways, through their physical properties and through their chemical properties. Physical properties are those that you can observe directly. For example, some common physical properties include color, odor, density, and boiling and melting point. Some of these are pretty obvious. For example, you can tell the texture or color of a substance directly. Some others are not so obvious. For example, density. You cannot just tell from one glance that water has a density of 977 kilograms per meter cubed. However, this is still considered a physical property because you can say this without reference to any other substances.
Physical properties themselves can be intensive or extensive. Intensive physical properties are unaffected by the amount of matter. For example, the boiling point of water does not depend on how much water you have. But extensive properties are affected by the amount of matter. An example of this is mass, because the mass of a certain substance depends on how much of it you have. Chemical properties, on the other hand, are impossible to observe independently. They can only be observed when the chemical reaction takes place, resulting in a change of the physical properties of a substance. Some common chemical properties include toxicity, flammability, and reactivity.
In this case, the answer is E. Lead has a density of 11.34 grams per centimeter cubed. You may have noticed that among all the other properties listed, they are only observable when two or more substances are involved. This is a common theme among all chemical properties. For example, we can only see the corrosiveness of sulfuric acid in action when another substance, like a metal, is exposed to it. With the density of lead, you don't need to have another substance to be able to say that lead has a density of that much. If you go through all the other answer choices, you will find that you can say those choices without reference to any other substance. However, with D, you have to say that gold is dissolved by nitric and hydrochloric acid. Without that reference to hydrochloric and nitric acid, that property does not make sense. Alright, now we will move on to physical and chemical changes.
Like properties, changes can be both physical and chemical. Physical changes alter the physical properties, but without affecting the chemical composition. For example, when ice melts, it's a physical change because the chemical composition of ice is still H2O, which is what water is.
Chemical changes alter the composition of the matter. Rusting is considered a chemical change because when the substance rusts, its chemical composition changes. When you mix alcohol and vinegar together, It is a chemical change because two new substances are generated, water and ester, a compound found in fruits.
When it comes to differentiating between physical and chemical changes, a reliable method is to ask yourself, is the change reversible? If the change is reversible, then it will be a physical change. If it isn't, then it will be a chemical change. For example, it is easy to turn water back to ice. You just have to put it in the freezer. But when it comes to turning bread back into uncooked dough, for all practical reasons, it is impossible. Another way to tell physical changes and chemical changes apart is through the 5 signs of a chemical change. The first sign of a chemical change is if heat is released or used up in the environment. That means if something becomes hotter or colder, a chemical change may have occurred. Reactions that become hotter or colder can be split into 2 categories, exothermic and endothermic. Exothermic reactions are the ones that release heat into the environment because bonds are formed. An analogy to this is the way the penguins huddle together in the cold, and after all, they are bonding. A real-life example is the way that the sun undergoes nuclear fusion, and through that process, heat is released, and that heat is what keeps Earth habitable. The other type of reaction are endothermic reactions, where heat is lost in the surroundings. This is because heat in the surroundings energy is required to invest into a breaking of a chemical bond. A way to remember this is, let's say an ice cube cools your hand, so this means this is endothermic. The second sign of a chemical change is if gas bubbles are formed. That means if you combine 2 liquids together and gas bubbles surface, then a chemical change may have occurred. The third sign of a chemical change is if there is a change in color or odor. However, be careful here, because if you add something like food coloring to a liquid, although the color may have changed, there was not a chemical change. The fourth sign of a chemical change is if a precipitate is formed. That means if you combine 2 liquids and a solid forms, that is one of the signs of a chemical change. The last sign of a chemical change is if the starting material was used up.
We have an experiment here to test your skills at differentiating between physical and chemical changes.
In this experiment, I have a beaker of acetone, which is nail polish remover, and some styrofoam. Now watch what happens when I put the styrofoam inside the acetone. Notice how there are bubbles being formed as the styrofoam melts away. Would this be a physical or chemical change? It is easy to assume that this is a chemical change. After all, gas bubbles are released, a sign of a chemical change. But believe it or not, however, this is actually a physical change. When the styrofoam is put in the acetone, the air from the styrofoam is released, creating bubbles. However, the chemical composition of the styrofoam remains the same, despite it looking different. That's why this experiment is actually a physical change. If anything, this experiment demonstrates a key concept, that the 5 signs of chemical change are just simply signs. Although gas bubbles are usually an indicator of chemical change, a more reliable method would be to look for more than 1 sign. Now, let's check your knowledge of physical and chemical changes.
The other answer choices are incorrect because if you look at them, all of them have at least one of the different signs of a chemical change present. For example, when you blow torch sugar, the color changes. However, when water turns into a gas, which is water vapor in this case, it is still water, it is still the same H2O. So this can tell you something very important. Changes to the state of a substance, they're all physical changes. Those changes in the state only reflect a change in energy, not a chemical change. For part A, a leaf grows out of a bud. Well, that one is chemical, because you start with a bud and you end up with a leaf. You end up with a completely different substance, so it can't be a physical change, it will be a chemical change. For part B, your sweat evaporates to balance your body temperature. Though sweat is basically water, as the water evaporates, do the same H2O, so it would be a physical change. And last, For part C, that would be a chemical change because the food is reacted with things such as stomach acid, so that would be a chemical change.
Today we learned about almost everything around us, matter. We then established some differences between physical and chemical properties, such as the presence of a chemical reaction. And finally, we finished with the 5 signs of chemical change. If you believe that you still need some more practice, we've gathered similar questions and put them in the description box below.
This video script was edited by Science Saiha, Ziber Yuan, Keelan Zhang, and Andrew Xu. The video was animated and edited by Keelan Zhang and Ziber Yuan. The intro animation was done by Jessica Xu, and thank you to Julian Tan for the original intro music. That is all for this video, and we hope that you join us next time.